Hello, this is Keenan Park, and this is YLOC 4th grade worksheet, lesson 11. For our first section, we have prime factorization, which is just splitting a number into its prime factors. Like 12 is the same thing as 2 squared times 3. 2 is prime and 3 is prime. So this is its prime factorization. Okay, 6 equals, 6 is divisible by 2, so that's one of it. And then 6 divided by 2 is just 3, which is another prime. So it's 2 times 3. Using a similar process, we can get 3 times 5 for 15. 36 is interesting. You can notice that it's 6 times 6, and 6 is 2 times 3. So it'll be 2 times 3 times 2 times 3, which you can write shorter as 2 squared times 3 squared. 121 is 11 squared, and 11 is prime, so there's no need to factorize further. 108, you can notice that you can divide 4 out of it, and 4 splits into 2 and 2. And once you divide by 4, you'll get 27, which is 3 to the power of 3 actually. So your answer will be 2 squared times 3 cubed. 144, you'll notice, is 12 times 12. So we just need to factorize 12, which is 2 squared times 3. And then because there are 2 of them, the exponents will be doubled. So it'll be 2 to the power of 4 times 3 squared. 840. This is a pretty big number, so we'll use the tree like before. You can divide this by 4, and then that will give you 210. 4 splits into 2 and 2. 210 can be divided by 10, which splits into 2 and 5, and leaves you with 21, which can be split into 3 and 7. So our prime factors are 2, 2, 3, 7, 2, 5, or we can write them more simply as 2 to the power of 3 times 5 times 7. And then lastly, a fun one, 1024. This is actually just equal to 2 to the power of 10. That's it. And then here we'll find the lowest common multiple and greatest common factor. So the lowest common multiple is the smallest number that both of these are factors of, or that is a multiple of both of these. So in this case, this is 12, because 12 is 6 times 2, it's a multiple of 6, and it is 4 times 3, which means it's a multiple of 4. The greatest common factor is the largest number that is a factor for both of them. In this case, that's 2, because this is 4 is 2 times 2, and 6 is 2 times 3. You can use the prime factorization to find the GCF easier. 15 and 8, we can see that 15 is 3 times 5, and 18 is 2 times 3 squared. So to find the LCM, you can just multiply these together, but any repeats like the 3, you'll ignore the smaller one. So in this case, it'll be 2 times 3 squared, because we're ignoring this 3, times 5. And if you calculate 2 times 3 squared times 5, you'll end up with 90. The greatest common factor would be what they share. So in this case, that's just the 3. They only share a 3. So the GCF is 3. 14 and 49, the LCM is 98, and the GCF is 7. Because this is 2 times 7, and this is 7 squared. 8 and 12, the lowest common multiple. If 8 is 2 thirds and 12 is 2 squared times 3, so the lowest common multiple will be 2 cubed times 3, which will be equal to 24. And the greatest common factor is 2 squared, which is the same as 4. 18 is, as we previously said, 2 times 3 squared. 210 is, I believe it's 2 times 3 times 5 times 7. So we can see their GCF. I'll just do that one first because it's easier. It would be 2 times 3 because that's what they share. And then their LCM will be 2 times 3 squared times 5 times 7, which is 210 times 3 if you notice, which will be 630. We have 19 times 12. 19 is a prime number. And so when you find the LCM of a prime number and something else, it will just be equal to, well, actually no, there's no rule. But then this is 2 squared times 3. If they have nothing in common, then you can just multiply them. So we'll do 19 times 12. We'll get 38. and then 190, add them together to get 228. So the LCM is 228, and the GCF will be 1 because they have nothing in common. And here we have 26 and 78. An interesting thing is that 78 is actually just 26 times 3. So the LCM is 78 and the GCF is 26. And lastly, we have 140 and 196. 140 is 2 squared times 5 times 7. 196 is, I believe that is 2 squared times 7 squared. Yes, it is 2 squared times 7 squared. So their LCM will be 2 squared times 5 times 7 squared, which is 5 times 196, which would be 980. And then the GCF would be what they share, which is 2 squared times 7, which will be 28. And then lastly, onto word problems. Nathan is buying eggs, and the eggs come in dozens. He has 15 raccoons and wants to give them the same number of eggs. So to do this, to find the smallest number of eggs, we can just find the LCM of 12 and 15. And the 12 is because this is dozens. The LCM of 12 and 15, well, 12 is 2 squared times 3. 15 is 3 times 5. So the LCM will be 2 squared times 3. We ignore the 3 and times 5, which will be 60. Kaylee is expecting a shipment of trophies, but she can't remember if she ordered 16 or 196. Very odd, but what is the largest number of boxes she can use to evenly distribute the trophies into without leaving any out, which will work for both numbers? In this problem, we're just trying to find the uh, greatest common factor because we're trying to find the largest number of boxes that would evenly distribute both trophies, or both trophy counts. 16 is 2 to the power 4. 196 is 2 squared times 7 squared. So they have 2 squared in common, which is just 4. And then challenge, I want to find how many factors, not just prime factors, but factors the number 720 has. This is one number, so 720,720. I know that this is the prime factorization. That's kind of a lot. And it'll be hard to find out what the factors are. But there's actually a special trick to finding this, which would be if you add 1 to each of the exponents, let's pretend there's a number exponent 1 here, 1, 1, 1. You can add 1 to each of these exponents. So we have 4, 2, 1, 1, 1, 1. And then we'll add 1 to get 5, 3, 2, 2, 2, 2. And then you can multiply all of these together. And then that will be the number of factors you have. Oh, this is not supposed to be prime factors. It's just supposed to be factors. Sorry. So this number is, I believe it is 240. And so the reason this works is because you can think of these prime factors as sort of switches, or like levels of a switch. Where 2, we have at the maximum, we have 4, 3, 2, 1, 0. And then we can have anywhere from 0 to 4 2s for our factor. For 3s, we can have 2, 1, or 0. For 5s, we can have 1 or 0. And so you can see the number of options they have 1, 2, 3, 1, 2, 1, 2, 3, 4, 5 is the exponent plus 1. And then each combination, like 4, 0, 1, is a unique factor. And then so the number of combinations is this, the number of options times the number of options times the number of options. And so that's why this works. That's all for today. Thank you for watching.